Okay, 6-digit LED clock project. So there was a short delay on this after me opening the package originally because, look, no instructions. So I contacted the seller in China and they were quite happy to send me a large PDF with 6 pages of instructions. So don't panic if you get one without instructions. So just have a quick look at what we get first. Oh, didn't notice that little peg before. That's interesting. Okay, so we've got 2 end pieces. Don't think that belongs to anything actually, but put it to one side just in case. So you've got 2 end supports, a PCB, which is always useful. I don't like most PCBs. You actually mount the components on the side that has the image of them, the markings. And there aren't many in this. And then we have a filter to go over the LEDs. The first thing you'll notice is that it's a 6-digit clock and it only has 5 LEDs. Oh, what joy. So I did some research and found out that it doesn't actually use the full width of each digit, so that's not a problem. And also, these things actually contain a filter. Now, this glossy filter on them to protect them, but actually if you take it off you'll have a nice matte background, and that will give you a much better display because there's enough filtering going to be going on when this screen is over it. And yes, I confess, the thing that got me really interested in this project was another YouTube channel which you'll find in my playlist and favourites. Sorry, I'm just blowing bits of polystyrene out from between the pins. So yeah, BigClive.com on his channel assembled a 4-digit version, and he did raise the question about the accuracy of this clock. So I contacted him. He said he would investigate the timekeeping quality and hopefully come up with an improvement in a future episode. Well, frankly, the timekeeping can't be that bad because he's never come back and done it. So if the timekeeping is atrocious, I've already warned you. These things double up as bases. Well, they would do if I could separate them. There we go. Anything that is moulded plastic inherently has a bit of static electricity bonding it together. So yeah, this one obviously goes between the LEDs and the board, underneath obviously, not on top. So yeah, this goes underneath the LEDs, not on top of them. I'm just going to stop there and do a review. Okay, so obviously we've got a micro USB power lead, and in addition to these parts, which I'll put to one side for a minute, we have a little bag of tricks, a little bag of components which is impossible to get into, just to make life interesting. I may regret doing this. The version of the kit that Big Clive did actually had full-size chips in. This one has surface mount ones, so it's going to be a little bit different. A little bit. I was going to say more interesting. That's not technically the right word. And I believe this is speech activated. So it's got a microphone and it's got a beeper, whether it's a beeper or a little loudspeaker, slightly unsure there. Some screws and some nuts. Yeah, nuts and bolts of any project. A tiny surface mount electrolytic capacitor, a battery holder, doesn't come with a battery, and a light sensor so that we can calibrate the brightness to automatically change according to the amount of light on it. These are one of life's more interesting components because the first ones that I remember coming out were about 12mm across, and it was called an ORP12. And over 20 or 30 years that I've been messing around with electronics, they've shrunk down, and this is probably about 5mm across. And the other components are in batches, and I believe these green ones are LEDs. They're going to be quite interesting to work out which way round they go. I believe they have a green dot on the anode. And also another YouTube channel, and I can't remember which one it was, but again, it'll be one of the ones that's in my playlist. Found out you could identify the correct way round for any LED by simply applying a multimeter on the diode range so that it's putting about 3 volts across it. It will actually not only give you an indication of the resistance, it actually illuminates the LED. Not bright, but enough to tell you if it's the right way round. Now, until I unwrap these, it's going to be difficult to tell what they are, because my eyesight isn't getting better with age, and I will require the services of the magnifying glass. But for anybody who's building any of these projects, this is called a helping hand, and they are really useful because when you're soldering, you inevitably need to hold the iron, the solder, the component, and we're only born with 2 hands, so at least you get 2 extra ones here to assist, and a rather malformed magnifying glass. This at least provides a bit of help, so that's going to be quite interesting. Now, you need a couple of other things for working with surface mount components, so I'll talk about those briefly. Normal solder, this is 0.6mm solder, 0.8mm, I beg your pardon. So this is 0.8mm solder, and it's also the modern solder that is lead free. If anybody's ever worked with this, it's not too bad for soldering thick wires together and soldering normal sized components onto PCBs. Obviously they've taken lead out of it because lead is harmful to the environment, but it's flipping useless for soldering surface mount components for 2 reasons. Firstly, it hasn't got lead in it, and secondly, it's too thick. So you can, with a little bit of research, you can buy this stuff, and I can't remember what size it is, but it's less than 0.5 millimetre, and you can see the difference side by side there, because if you're using this with a big iron that I'm going to clean before I start using it, the second that this hits it, by the time the heat from the iron has melted it, you're going to end up with a big blob on your component. And especially for these surface mount components, the chips, or ICs as we call them in my day, integrated circuits, the second you get a blob of solder on there, it's going to be an absolute bugger to remove it. But you can control this better with thin solder. But there's a second thing that you need to make it successful soldering joint: flux. And again, this I think was £2.99 in UK money, and it needs to be applied with a brush. Ooh, maybe is that a brush I see in the bottom? Maybe the brush just fell off. So this watery liquid, oh there we go, comes with a brush, there you go. we can apply to the circuit board before we fit the components, and once we start soldering it should run like magic. Now if you're a beginner to doing surface mount components or soldering, it is tricky when you first start. I worked in electronics for over 20 years and I saw surface mount components come in gradually, get smaller gradually. If you look at the pitch on these, I'm not even going to attempt to work out how small they are, but it's going to be a little bit tricky to solder. So you need patience and practice. It's not a good idea to practice on your first project. It's a good idea to get a scrap circuit board and practice removing the chips and refitting them. But to remove them you need a hot air gun or a reflow station that will literally provide a very fine flow of air, temperature controlled air that's not too hot. I've seen a few people doing it other ways, which is fine if you've got a scrap board and you want to get all the components off, but it's a bit brutal frankly. The best thing to do with soldering these type of components, firstly only undo each packet as you need it, because they're an absolute sod to identify the components once if you get them mixed up. And the other thing, what is the other thing? The other thing is to install the smallest components first. So this is going to be interesting because I've never actually built a kit. I used to repair electronics and I've designed electronics, but never using surface mount components because it was a few years ago. So I'm going to have a little pause and get my instructions out. I'll give you a glance of the instructions. Here they are on this glossy white paper. And quite interestingly, it says, first line says, please carefully read the entire production process and then do it better. Fair enough. In other words, they didn't do a very good job of it. Never mind. So ideally you should have a temperature controlled iron. The iron should be grounded. In the UK that's not a problem, we ground everything, as a lot of people point out. And they use words like welding. Well, I beg to differ. Welding is joining two similar metals together with an electric current or a flame. Soldering is using a dissimilar metal to the copper that you're soldering to. So just change the word weld for solder. Pronounced solder, not solder, like certain countries seem to name it. And you can only really tell what's what by the number of them. And yes, they've got these little legends, so a 1 mega ohm resistor is 105, and on SMDs, instead of being colour coded, they actually have the digits 105, but the initial way to identify them is that there's 2 of those, 4 of those, 1 of those, etc, etc. So that way you only need to unbox what you actually need to do. So let's move some stuff out of the way a minute. And I did in fact sweep up the component that I wanted. Is this a 105? Oh, and the other thing that is going to be very, very useful, and I didn't have one, so I did actually, I still can't see that, I'm going to have to get a proper magnifying glass. The other tool that you're going to need, and I've just purchased one, so if I go over to my new toolbox, is a pair of tweezers, and I actually bought 5 of these different style ones for a couple of quid. They're just about impossible to handle. If you start using a pair of pliers or something, it's going to be brutal. So there we have it, pair of tweezers, and I got 5 different tweezers for about 3 quid or something, £3, £5, whatever. Okay, so I've moved in close because if you can see these resistors, You're a better man than I am, because I can't. I can't see that, I can't see the number on it. We're going to have to take it at special value, that's what it is. And these are R1 and R2. So, R1 and R2 go in those two positions. So the first thing we need to do, it's much easier to work end on, is to tweeze a bit of solder on to the board. And before you start, it's a good idea to clean the soldering iron. And the most effective thing is a damp cloth. Just very quickly drag it over like that. And immediately just put some tin on. So we want to fit R1 and R2. Let's see if we can do this. I have honestly never worked with components quite this small. So the trick with soldering is to apply heat to the component and the board at the same time. And that didn't go according to plan, as the eagle-eyed among you will notice. It's a little runaway. And also these appear to be very small compared to the size of the pad it's going onto. That's two. That's just tacking it to hold it at the minute. So now we can apply heat to component and board together and run the solder in. And then for neatness, we'll just go back and do the other side again with some fresh flux. Don't need the special flux for this. Bring that under my magnifying glass, and that's okay. Nothing like shorting out or anything. I really wish you could see the value on the resistors, that would be interesting. So the next ones are R3 to R7.